Okay, so today we're going to skip over and start talking about lines and the equation of lines. You started to see these formulate last week when we were doing the in-class activity, and also a little bit here or there in the last, when we were back in Unit 1 or Module 1, but today we're really going to get into this slope-intercept form. So the first thing that we're going to explore is the actual equation of a line. The way we're going to see it, we're going to actually see it two ways, and I'll show you both ways. We're going to see this idea of y equals mx plus b. And I know you saw this in 7th and 8th grade as well, where m is going to be our slope, which is how much something grows or decreases by, and b is your y-intercept. Okay, y-intercept. A y-intercept in here, something very important to understand, a y-intercept in this class is when your x is equal to 0. If you really think about that, that's exactly what a y-intercept is. A y-intercept is when it crosses the y-axis, like at this point right here at 2, I have a y-intercept. Well, you always have to know that when you're talking about an y-intercept, that means that your x is equal to 0. So that point is going to be 0, 2. Okay, so that will be an important concept moving forward in understanding that when I talk about a y-intercept, it means when x is 0, because that's going to have context later on built into it. When I say that there are two ways you're going to see it, we now learned this new way of f of x. Okay, is equal to, it's still the same though, mx plus b. I want you to understand that sometimes I will use y and sometimes I will use f of x. The reason that I use f of x and I prefer it is because at the end, if you guys tell me, oh yeah, y equals 4 because you plugged in 2 for x, well, I have to go back and search to find out what you plugged in for x. But here, if you put f of 2 is equal to 4, then I know what you did. You plugged in 2 and you got the answer of 4. So this is kind of a better way for me to see more of the picture when we go through. So those are the two different ways that you're going to see this equation, and the only difference is that sometimes I will use f of x instead of y. Okay, so now moving into the idea of a line. There's this wonderful tool here that we're going to actually talk about. It's called the line factory. It says if you, and in class, obviously we would explore this. I would have you guys go through and actually look at all the different lines. We're going to look at a few of the scenarios so that you can see how you would build the equation of these different lines. Okay, so in this it says you are an engineer at the city's premier line factory. Your job is to process customers' orders for lines. Analyze the recent orders below. If a customer has provided enough information to produce one, and only one line, then pass it on to your production department and write the equation of the graph. However, if you do not have enough information to draw one specific line, draw at least 2 lines that fill the order and send it back to the customer. Okay, so I'm going to actually get into the Desmos tool because in this one it goes through and it talks about all of them. A line A that goes through 0.25. Well, okay, so let's explore that one. They've already populated a tool with 2 different lines here for us. If I'm looking specifically at that one, a line A goes through goes through the 0.25. Well, that's this point right here. And these lines are just random right now, so don't think that they mean anything yet. I'm going to move them to make them mean something. If the line goes through at 1, 2, up 1, 2, 3, 4, 5, I'm going to move this point actually up there. Is there one specific line for that one that will work? Well, I just made one work right there, but couldn't I also like move this one over like this and then have a different line? Actually, all of these lines work. Now that I'm looking at it, if they only give you 1 point, then all of these different lines with different slopes could work for this line. Okay, so in this one, we don't have one specific line. So I'm going to write the equation for 2 different lines, they said. So now I've got 2 lines here that I've built. Okay, and I just landed on this. Well, I'm actually going to make it a nicer slope-intercept for both of these, or a nicer y-intercept, just so that we have them. Let me see if I move this down here. Doesn't look like it's going to go through at a nice number. So maybe I go like this, and I slide this point there. There we go. Now I have a nice y-intercept, right? I have a nice y-intercept, and it still goes through at 10, 5. I want a nice y-intercept for this one too. In fact, let's make my y-intercept 2. Okay, so now I've got nice y-intercepts, but I've got 2 different lines that I can give this person that go through the point 2, -5. So let's go ahead and write the equations. This is where I'm going to use y for now. Y is equal to, I need a slope times x plus my y-intercept, okay, plus my y-intercept. Well, for line number 1, I'm going to do my green line. My y-intercept is 2 when x is equal to 0, so I'm going to put the 2 there. Okay, so what's my slope? Well, I go up to go from here. You always go from right to left. I go up 1, 2, 3, up 3, okay, up 3, that's a positive 3, over 1, 2, over 2. Okay, this is always going to be, and you may have heard this before, rise over run, or y's over x's, your change in x's. Okay, so your y's over your x's. So it's rise over run, up 3 over 2. My answer for my line is 3/2 times x plus 2. Okay, so that's my first line. My second line is right here, this guy. So on this one, when I have y equals blank x plus b, okay, you're going to see me do that a lot because now I can fill these in. My y-intercept is up at 6, 0, 6. So I've got my y-intercept. But now my slope, I go down 1. Remember, you always do your y's first. I go down 1. Well, when I go down 1, that's a -1. That's a -1. But I still go right, which is positive, 1, 2. Right, 2. -1/2 x plus 6. Okay, I want you guys to continue to see these. So in the book here, the next one says that line B has a slope of -3 and goes through the origin. Okay, so I'm going to kind of just move this line out of the way for now because I'm only going to deal with the green one. So I only am looking at the green one at this point. So in this one, it goes through the origin. The origin means 0, 0. So it goes through the origin and it has a slope of -3. Well, this has a slope of 1, 2, 3, 4, 5 over 2. That's definitely a negative slope is going to go this way, right? Like it's going to go that way. So now I just need to figure out, like maybe it goes there. Maybe it goes there. Let's check our slope. I go down 1, 2, 3 over 1, 2, 3. Down 3 to the right 3, that's going to give me a slope of, oh no, that's -1, right? When I simplify it. So what I want to do is I want to go down 1, 2, 3 over 1. I want to move that point right there. It has a point at the origin, then it goes down 1, 2, 3 over 1. If you guys look, that's the only line that I could possibly have. If it goes through the origin and it has this slope, there's no other line that this could be. There's no other line. This is a single equation. So like in this one had multiple equations that could go through it. I did not have enough information to commit to a line. This one is only going to have one equation. And it's going to be y is equal to, here's my m times my x plus my b. Okay, my m is down 3 over 1, -3 over 1, which is just a slope of -3. Plus, my b is my y-intercept, which happens to be 0 here. So the equation of this line is actually just y equals -3x. because I don't have to put the +0. You guys are welcome to leave it in this form. I would never mark you down for that. But that is the final equation for this one. Okay, let's do a couple more. So it says here that for the next line, we're looking at line C. So I'll go with green again for a minute. And line C goes through the point -3, -2. So let's do that. -3, -1, 2, down there, -3, -2. And it goes through the point 3, 10. Okay, so let's move this one up to 1, 2, 3, and then all the way up to 10. I'm blocking it, so let me move my screen here. 3 up to 10. There it is. I'm going to move, again, the purple line out of the way completely just so we don't have to worry about it. Okay, so we have now our point. Let me double check again. It goes through at -3, -2, and it goes through at 3, 10. Oh, okay. So guess what? That's my only line. That's the only line that will go through those. So let me go back really quick. This one, when I was given a single point, I was given the point, let me remember here. It was going through 2, 5. When I was given a single point, I had many lines. But when I was given a point and the slope, I only had one line. Here in C, I'm given 2 points, and guess what? We're only going to have one line. So let's find the equation of the line. Y equals blank x plus blank. Okay. Well, my y-intercept is 4. That's nice. It has a nice y-intercept. My slope, I always go from like one of the points on here to another point on here to the right. So in this one, I'm going to go from this y-intercept that I just said, that one, up to this point right here, because I have that point right on the line. So I go up 1, 2, 3, 4, 5, 6. I go up 6, that's +6. And I go over, now I run over 1, 2, 3. I go over 3. Oh, but I realize I can reduce that, right? 6 divided by 3 is 2. So actually the equation of my line is 2x plus 4. I'm going to double check that with another point on the line. So if I go up 1, 2 over 1, oh yeah, that looks like a point on the line too, right? Up 1, 2 over 1. Yep, there's another point on the line, right? So that indeed does work for this equation. Okay, let's do one more and then I'm actually going to go to, you know what, I'm going to click out of this. You've now seen the 3 different examples. The main thing that you needed to gather from this is to understand that, oops, let me leave this. There we go. The one thing that you'll need to understand is that when you're given 2 points, then you can form a line. When you're given a point and slope, you can formulate one line. But if you're just given 1 point, it could be many lines that would be. We're going to encounter these 2 different examples. We're going to be given 2 points, sometimes even more. Like look at in D, they gave 4 points, but we're going to use 2 of those points, 2 points, to form a line. We're going to use a point and a slope in order to figure out the equation of a line. Those are going to be the 2 ways that we find out one single equation for a line. Okay, and let me see. I think I'm going to actually do this one. What I would suggest you guys do tonight is when you guys are building these, I would actually highly suggest that you draw these or go to Desmos.com and put them in to figure out the equation so that you can see them. So you'll see me model that in a minute, but I do want to show you without a graphing calculator how you could do this. So if you're given 2 points, without a graphing calculator that goes through the point, let's say 4, 15, and to 11, I want to show you how I would go about doing that. Our slope is actually what we would have to find first, because neither one of these is my y-intercept. A y-intercept is going to be when x is 0, and x is not 0 in either one of these. So we have to first calculate our slope. The way we're going to calculate slope is you can take your y's over your x's. I think of like rise over run, y's over run. What we do is we figure out what the changes in our y's are. So I'm going to take 15 and I'm going to subtract 11. I'm going to take 15 and I'm going to subtract 11. That's how we find out a change in our y. It looks like here my y changed by 4. And then I do the same for my x's, but it's really important that you do them in the same order. So like in this point, I would have to have the 4 on the bottom here. I did 15 minus 11. I have to come back and do 4 minus 2. Okay, so my coordinate points actually line up with each other. So then I do 4 minus 2 on the bottom. That's the change in my x's, how much I changed in my x's. So I'm going to show this in my graph as well, but I have 15 minus 11, which is going to be 4, over 4 minus 2 is 2. 4 divided by 2 is just 2. That means that my slope, my y equals 2x plus, and what I don't know is my b. Okay, I'm going to stop there for just a minute, and I'm actually going to pop Desmos open. So if I go to desmos.com, and I believe I have to sign in. Nope, it's already signed in for me. So I'm going to go to the graphing calculator. If I go through and I put in these coordinate points, so I'm going to put in the point, let's do 4, comma 15. Okay, and then I'm going to put in another point, and I have to zoom out to see it, right, because that's pretty high. I'm going to put in the coordinate point 2, comma 11. 2, comma 11. So there are my 2 points. I'm going to kind of zoom in a little bit. So what I just found is that my slope is 2 over 1. Let's see if that holds. I go up 1, 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Yep, it totally looks like I have that, right? 2 over 1. So I'm going to start building that. I'm going to put y equals 2x. But do you see the problem? My y-intercept is definitely not 0, right? Like it's not plus 0. It's going to be plus some number. Plus what? Let's guess. Let's say it's plus 5. Nope, not quite there. It doesn't line up on my dots, right? So it's not 5. So let's do 2x plus 7. Oh, there it is. Look it. I guessed. I guessed right. So my line is 2x plus 7. Yay, I'm done. Here's the problem. We don't actually want to guess. I don't want you guys to try to guess what the y-intercept is. Yes, did I find it? Sure. I found it after I found my slope. But I want to actually know how to calculate my y-intercept. To calculate this y-intercept, when all we had was y equals 2x, the way that we're going to calculate it is that we have this plus b. Like I don't know what my y-intercept is. All you have to do is plug in one of these points for x and y in here, and it will give you your b, because these points are both on my line. They're both on my line. So let me just pick one. I'm going to pick 211. I'm going to pick 211. It doesn't actually make any difference at all. I'm going to actually plug that point in here. For y, I plug in 11. 11 equals 2 times. For x, I plug in 2. 2, and then I have my plus b. This is 11. This is 4, so I'm going to subtract 4 really quick. If I subtract 4, 11, so 10, 9, 8, 7, 7, I end up getting b equals 7. B equals 7. Well, that confirms my answer. Okay. Okay, you guys are going to practice this concept. You're going to practice this concept tonight. If you're given a slope, it's even easier because all you do when you're given the slope, you don't have to find it. You don't have to use this y1 minus y2 over x1 minus x2 format. You don't have to do that. You skip straight to this step where you plug in the point that you're given. You plug in the point that you're given. Okay. Good luck with your work.